Let's also demonstrate some examples with string literals in our paper computer exercises. So let's try number 27. If we use a literal string, of course, literal string in itself is not a complete statement, so then we can again indicate that this is an expression. And as we discussed earlier, such expression returns the address of the first character allocated in computer memory. So let's just throw this sequence of characters somewhere in this memory fragment, and how about we choose this last section of our memory, starting with address CC, and then C, D, E, and F. Of course, as we begin to store our character literal, which is ABC, the first character will be stored in this location, then there will be character B, and then character C, and of course we know that every string literal is terminated by a null character, a character with all zeros in its bit pattern. So the type of the data that is returned by this expression, we say that every expression in C++ has a type. So the type here would be a complete type, would be character, which is constant character, and we return the address of it. So this is the data type returned by the string literal. And of course the numeric value is the address of the first character of character A in our simple memory example. So that would be something that looks like hexadecimal CC. Now if we try some strange uses of indexing with a string literal, we could attempt to do something like this. Because this string literal returns the address of the first character in memory, we can use this expression ABC as a base address to the entire memory block allocated for these characters. So obviously indexing or subscript operator using square brackets and specific index would instantly dereference the address returned from or by string literal, and this would give us access to this character B. So this would actually return character B from this block of memory allocated for our characters. Therefore, I'll just write that the numeric value returned by this expression would be character B, and the type is simply a character, and this of course is another expression. Another somewhat similar and a little strange looking but similar example would be to dereference a string of characters like this. Well, you know that dereferencing is equivalent of using index 0, so this would be totally equivalent to saying ABC index 0. So similar to this, obviously this would dereference this address, which is an address of a constant character, so this would return us character A. And again, the data type here is character, and this is an expression, so this is all similar. And this other example, of course, would demonstrate the same outcome. They're basically the same expressions. And let's conclude this presentation of different uses of memory addresses, placement of variables, addresses accepted by pointers, those addresses dereferenced by different pointers. So we can say char const pc equals ABC. Right, so we're creating new pointer in our memory. Let's just store it somewhere in the next available memory cell, and I'll say that this is our PC, and of course its size is also the same as the sizes of integers, and because the address of literal string ABC in our case happens to be 0xcc, we'll just copy and paste this value right here to indicate what it stores. I'll just store it like this as a hexadecimal value. And notice that although I'm using a few times literal string ABC, regardless how many times you're doing it, most compiler will store it, will realize that this literal string has been used already, and it already has a memory allocation. Normally it's allocated statically. This is why I put this on the side, and this is typically a read-only memory. And so when we're using it in different sub-expressions multiple times, it doesn't change anything in its storage. The string is stored only once. The null terminating character is appended at the end of the string, and of course as we create the pointer, it will be pointing to the first character right here, and this will be a pointer to a constant character, indicating that we can read the value from this memory, but we cannot change it. And that would be, of course, another example of a pointer, so that its type would be constant pointer to a character. And of course this is a complete declaration of a new variable named PC in our fragment of memory.